We now move on to the 13th and final stage of the project. In this stage, we calculate specific probabilities using the copula model. These probabilities pertain to individual variables, joint probabilities, and conditional dependencies. The calculations are performed using the Clayton copula defined in stage 9 and the kernel estimated CDFs for x1 and x2 obtained in stage 12b. In point A, we compute the probability that x1 is less than or equal to 0. The argument u1 is assigned the value of the marginal CDF for x1 at 0, which is calculated using the pKDE1D function from the KDE1D package. The probability is then computed using the pCopula function from the copula package, following the formula written in gray. In point B, we compute the probability that x2 takes values greater than 0. First, we calculate u2 using the kernel estimated CDF for x2 at 0 with the pKDE1D function. Then, we use the pCopula function to compute the probability by subtracting the Clayton copula value at point 1, u2 from 1, following the formula written in gray. In point C, we calculate the joint probability for both variables. Using the pCopula function, we pass u1 and u2, which correspond to the estimated marginal CDF values for x1 and x2. The joint probability is computed according to the formula written in gray. In point D, we calculate the probability that x1 is greater than 0.2 while x2 is less than or equal to 2.5. The formula written in gray indicates that this probability is obtained by computing the difference between the marginal CDF of x2 at 2.5, denoted as u2, and the Clayton copula value at point u1, u2, where u1 and u2 are estimated using kernel CDF estimators at 0.2 and 2.5 for x1 and x2, respectively. Finally, in point E, we compute a conditional probability, the probability that x1 is less than or equal to negative 1.23, given that x2 is greater than 0.64. These calculations require, as indicated by the formula written in gray, computing the values of the copula and the appropriate marginal CDFs, with the final probability being derived as a quotient of the relevant differences. With these calculations, we conclude the entire project, which focused on modeling random variables using copulas and drawing probabilistic inferences based on variable dependencies.